In this video, we're going to look at recursive formulas and absolute cell references. So what exactly is a recursive formula? This is what we're going to start with. A recursive formula is a formula where the value of a term is determined by using one or more of the previous terms in the sequence. There's a lot of new stuff coming at you right at the beginning, but let's try and simplify it a little bit more. So let's just say I want to have a list of numbers. I want it to go 1, 2, 3, 4, 5, 6. So how could I end up doing this? I could start with the first number, and I could just end up taking that number and adding 1, equal to the previous number. We select the cell above, and we go plus 1. Now what happens if we take this and we fill it down? Well, if we were to just fill down one square, or one cell, you have the option to fill using this little menu up at the top right, fill down. You also have the ability to press Control D, and you can also do that in many other cells too. So we're going to get to see this in a bit. I'll demonstrate in multiple ways. But what exactly is happening here? Well, this cell is saying do the one above it plus 1. And when we go down, it's saying do the one above it plus 1. And this one's saying, well, 3 plus 1 is 4. We could also change this up to be something like equal to 1 plus 2. And then every single time that we go down, it will add 2 to the top cell. So the next one, if we fill this down, Control D, will be 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9, and so on. Now, it might not seem like, oh, I'm never going to use this. This doesn't really seem that useful. But when you're working in Excel a lot, this becomes extremely useful when we want to make lists of numbers, and you don't want to have to type them all in. You also have the ability to fill something to the right. That should be in the opposite spots. If we want to fill something to the right, we go equal to this number plus 1. We take the cell that we want to continue the formula on, and we fill it to the right. So it's going to copy this formula and fill it to the right. We can go Control R, which will do it, or we could go back up to the fill options and right. What if we want to fill left? Maybe we want to start with the number 10, and we want to decrease each value by 2. So we select the cell, minus 2. And so when we take this and fill it to the left, it's going to decrease each value by 2. Fill left. I think it's also Control L. Could work as well. Control L, let's try that. Nope, doesn't like that. Must be some other shortcut for it. So typically L filling something left is not that popular. Filling right and filling down is a more popular option than the other two. These are what we call arithmetic sequences. An arithmetic sequence is where the difference between the terms is constant. In this case, our difference is 2. Going from 1 to 3 is 2, 3 to 5 is 2, 7 to 9 is 2, and so on. And we've also here got a consistent difference between the terms. 1 to 2 is going up by 1. So this would be an arithmetic sequence. And here's something where you could end up asking yourself, what is the sum of the first 100 natural numbers? In mathematics, a natural number is starting at 1, 2, 3, 4, 5, and it continues on forever. So what is the sum? How would we do this? We start by putting in the first number. I'd also like to emphasize here that if we selected a top number in what we're going to be doing and we go Control D, it's not actually filling down a formula because this is just a value. So this is also a way that we could just end up copying a whole bunch of values. We want to copy the formula. Equal to the number above it plus 1. And we're going to take this, the one that has our formula, we're going to scroll down. Now I already know, because I counted before I did this, that it finishes off at 107. Oh, it doesn't finish off at 117. It finishes off 2 spots below that, which is 119. So what is the sum of the first 100 natural numbers? We go back and we use our functions, equal to sum, and we can select all the numbers above it. Scroll all the way up, hold down the Shift key, and click the first one. Close off the brackets, press Enter, and so the first 100 numbers, first 100 natural numbers, the sum of it is 5,050. There are other ways to figure this out using formulas, but that is left for mathematics. Now, there's other kind of sequences that occur in mathematics too. One very famous one is called a Fibonacci sequence. This is a sequence where each number is the sum of the two preceding ones, starting with 0 and 1. So if we're trying to answer this question, what's the 20th number in the Fibonacci sequence? Well, let's start 0, 1, and so this next number is going to be the sum of the two ones before it. So equal to this plus the 1 2 spots above it. And if we fill this down, we'll just go all the way down until we hit this 20th number, Control D. We start to see, just let's take a look to see what's happening with the formula. It's saying, okay, well 1 plus 1, that gives us 2, and this should be 1 plus 2 is 3. And so when we fill our formula down, it's shifting the cells with it. So this is, again, another instance of a recursive formula. So in this case, the 20th number in the Fibonacci sequence is 4181. Just a quick note that if your cell or column is too narrow, that these little number signs come up. You can change that by just shifting it over until you end up having enough space to actually see the number fully. If, depending upon what's in the cell, snapping the line could either make it go really far to the right if something really long is in there, but it's not. So in this case, snapping the line would be just fine. So we've gone through filling down, filling right. Now we're going to take a look at a multiplication table. All we want to do is make a multiplication table of 5 times 5. And I've already set it up in some respects that will make our job a little bit easier. So let's just take a look at our numbers. Equal to this one plus 1. And I'm going to demonstrate how we can end up using filling cells or formulas. So I fill that to the right. I'm going to do equal to this one above plus 1. I'm going to fill this down, Control D. Now how do I end up making this so that I come up with a times table? Well, I want to do equal to this number, multiply the number above it, and there we have a multiplication going on here. Well, now what? If we take this and we fill it to the right, Control R, wait, that's not what I want. What happened? I'm confused. I expect that this one should be multiplying 1 times 2. Okay, that's okay. But this one, 1 times 3 is definitely not 6. What happened with this? Well, if we take a look, as we've shifted this to the right, our formula also shifted it to the right. And so it's taking the diagonals next to it and multiplying them. So this is 2 times 3. This is not what we want. How can we make sure that something's not going to change? And this is where absolute cell referencing comes into play. So up here in the formula bar, we see the C4 and D3. If we want to make sure that C, this column, never changes, we need to put a little $sign in front of it. So let's just see what happens if we take this and fill it to the right now. Control R. That's much better. So it's taking that number times that number. We're great, right? Now we can take these, and here's one of the cool things. We can fill these down, and it's going to take the formula at the top and fill it downwards. Control D. Wait a minute. 5 times 5 is not 600. Something's wrong. What's happening? That one looks okay. Oh, there's something going wrong here because we definitely don't want the 2 from here. We want it from up here. What about this one? Oh, okay, so as we fill down, it's also shifting the formula along with it. There's a big problem here. How can we make sure that we are consistently looking at this row? Again, absolute cell referencing. So if we want to keep it so that we're only looking at the third row, we need to put a $sign in front of the 3. And so this says when we fill the formula, it's only going to look at row 3. And we need to do that across the top here. Control R. Now we notice that the formula is now taking the $sign in front of the 3. And now when we take all of these numbers or formulas and we fill them downwards, Control D, everything works out quite nicely. So that is one way to do absolute cell referencing. We can do the same thing with dice. In fact, I'd encourage you to pause this and try and do this on your own before you see the answer. Equal to this number plus 1. Control R for filling to the right, equal to this plus 1. enter, fill this down, Control D. What's the sum of the dice? We're going to be equal to this plus, we're doing sum of K3. We want to make sure, what do we want to make sure stays the same? We want to make sure that column J stays the same, so we put a $sign in front of J. We want to make sure that this row stays the same. We put a $sign in front of the 3. Control R, Control D, and we have now created a sum of 2 dice chart. So it says 6 plus 6 is 12, and we can also click into the formula bar and see what's actually happening. What if we want to take a look at something just as simple as creating a graph or a set of points for a relationship? In this case, if we wanted to graph something, maybe we want to take a look at this, add 1 plus 1, and fill this down, Control D. So here's our x values, and here's our y values, where we're looking at a function or relation where the y value is x squared, equal to this exponent 2. If we take this and fill it down, what it's going to keep on doing is it's going to keep on squaring the number that's in the cell left on the left of it. Control D, and this is exactly what we wanted. What we'll see in another lesson is how we can actually graph this thing. Now, I'm moving on pretty quickly, I know, but I just want to emphasize there are other things at play. What if we have hours worked and we want to calculate pay? We could go equal to this, and if our wage rate is 15, we could go times 15. But here's a problem. What if we end up going up here and our wage changes to $16 an hour? All these other numbers didn't change with it. That's a big problem. How could we make this better? Equal to this number multiply by the wage. That's better, right? Let's fill this down, Control D. Oh no, something's not quite right. What happened? Well, as we filled this down, it also went down with it. Again, I'm going to emphasize that absolute cell referencing plays a role here. This here is V1. So if this is cell reference V1, we don't want to make sure that V1 does not change. $sign in front of the V so that the V column does not change, and a $sign in front of the 1 so that the row does not change. Filling this down, Control D. So now if we were to go back up here, notice that at the bottom it's multiplying the hours worked times 15. Okay, times 15. If we to change this one value, everything else changes along with it. That's the beauty of cell referencing, and it's really useful if you're doing something like currency exchanges and you need to change something in the whole sheet. I did skip past something here also, which is a geometric sequence. It's a sequence where each term is a constant multiple of the previous term. So here's an example of a geometric sequence. The population of bacteria is currently 5 and doubles every hour. What is the population of the bacteria after 10 hours? Well, we're going to call t the time, and we start at 0, and the current population is 5. Equal to, if we add 1 hour to this, plus 1, and over here the population doubles every hour, equal to the number above times 2. That's what makes this a geometric sequence, is that it is a multiple of the previous number. We can actually fill down more than one formula. Control D. And so this will tell us that after 10 hours, the population of the bacteria is 5,120. I hope after you've gone through this lesson, it's a lot of material to go through, but I hope that you understand the differences between filling right, filling down, filling left. Understand that there is great application to be done with mathematics here, and that absolute cell referencing, what exactly does it do is it allows you to look at a specific row or column. I hope you've enjoyed the video. If you have any questions, email me on just drop me an email, and you're also welcome to ask questions on the Google Classroom. Thanks for watching, and enjoy.